Welcome to this explainer. Imagine, for a second, that you're just floating out there in the vastness of space. Everything around you is calm, it's quiet, it's honestly beautiful. But then you notice something in the distance. Just a single point, completely dark. And it's not just an absence of light, it looks almost as if someone literally cut a hole in the fabric of reality itself. You're looking at a black hole. In this explainer, we're going to follow a doomed, theoretical stickman on a terrifying, totally linear journey straight into one of the darkest, most mysterious objects in the known universe. So, let's dive into this void.
So picture our stickman protagonist in his tiny spaceship, right? He's just floating peacefully, taking in the stars, enjoying a nice purple nebula, completely unaware of the absolute nightmare lurking ahead. Then, he turns and spots that tiny, dark circle far off in the distance, ringed with this faint, eerie orange glow. Panic immediately sets in. He tries to maneuver, but nope, it's too late. The engine just died. Sparks are flying, sweat's dropping. He is utterly stranded, drifting right toward an anomaly that completely defies human comprehension.
Now, before we follow our panicked friend any further into the dark, we gotta clear up a super common misconception. A black hole is absolutely not a giant space vacuum. You know, most people have this image in their heads of a black hole acting like some massive cosmic vacuum cleaner, just aggressively sucking up planets and stars from across the galaxy. But it isn't. It's actually a lot weirder and way more passive than that. Like, if you were to swap out our sun right now with a black hole of the exact same mass, the Earth wouldn't get sucked in. Not at all. We would just keep orbiting a very dark, very cold point in space.
To really grasp how powerful these things are, think about this staggering number, 300,000. That's the speed of light, in kilometers per second. To put that into perspective, that is fast enough to zip around the entire Earth 7 times in a single second. It is the absolute, unbreakable cosmic speed limit. But a black hole is a region of space where gravity has become so impossibly strong, so overwhelmingly dense, that it literally just stops light completely. Nothing gets out. Not a single photon. The gravity just straight up overpowers the fastest moving thing in the entire universe.
So how does something with that much raw gravitational power even happen? Well, it plays out in 4 incredibly violent steps. Step 1, it starts with a massive star, and we're talking about a star so ridiculously big that our own sun would look like a tiny glass marble sitting next to it. Step 2, over millions of years, that giant star burns through its nuclear fuel until it's just depleted. Step 3, without the outward pressure of that nuclear fusion, the star undergoes this catastrophic, violent collapse inward. And finally, step 4, all of that incredible mass gets crushed down into what we call a singularity.
And that brings us to the core of it all, the singularity. This is an infinitely dense, almost zero-sized point of crushed mass left over from that collapsed star. Just let those two phrases sit side by side in your head for a second. Zero size, but infinite density. It's a concept that completely breaks your brain, right? Actually, if you find that hard to wrap your head around, don't worry, because even the most brilliant physicists in the world aren't entirely sure what it actually means. The math literally breaks down at this point. But that tiny point is the beating, dark heart of a black hole.
The point of no return. Okay, so bringing it back to our doomed stickman, he's drifting away from his broken ship and toward the terrifying boundary that surrounds this singularity. That edge is called the event horizon, and it is the absolute point of no return. Cross that invisible line and you are not coming back, ever. And it's not because you hit a physical brick wall or because you explode. It all comes down to math. You see, escape velocity is the speed you need to go to break free from gravity. Well, at the event horizon, the escape velocity you'd need is faster than the speed of light. And since nothing goes faster than light, your fate is permanently sealed the exact millisecond you cross it.
And here's where we hit one of the most bizarre phenomena in all of science. It's literally a dual reality playing out at the exact same time. From your own perspective, or our stickman's view, if the black hole is massive enough, crossing the event horizon wouldn't actually feel dramatic at all. There are no sirens, no alarms, no sudden pain. You just casually drift right across it, totally unaware that you've just been cut off from the rest of the universe. But from the perspective of an outside observer watching you fall in, things get incredibly weird. The extreme gravity warps time and light so intensely that they would actually see time drastically slow down for you. You'd appear to turn redder, grow dimmer, and eventually just freeze in place. To the rest of the universe, you just fade away into a permanent smear at the edge of the horizon.
The spaghettification effect. But hey, that peaceful part of the journey? Yeah, it really does not last long. We are moving past those bizarre visual illusions and straight into the physically destructive climax of the stickman's descent. As you fall closer and closer to that infinitely dense singularity, the gravity gradient becomes insanely steep. That means the gravity pulling at your feet becomes significantly stronger than the gravity pulling at your head. At first, it's just a little tug, but then it intensifies super rapidly. Your body starts to stretch, vertically, pulled like taffy, stretched out like a noodle. This incredibly gruesome doom is what real, highly educated scientists officially call spaghettification. You are quite literally stretched into a microscopic, impossibly long, thin string of atoms, violently spiraling down into the center point.
It is simply not ideal. I mean, I think we can all agree that spiraling into a pitch-black abyss as an endlessly long noodle of atoms is a pretty terrible way to spend an afternoon in space. Our Stickman is, unfortunately, no more.
The epilogue: black hole death. Now that our guy has met his inevitable physics-driven end, let's zoom out a bit. We're going to shift our focus from the demise of whatever falls in to the eventual mind-bending death of the black hole itself. Because guess what? The void isn't permanent. If we map out the whole lifespan of a black hole, we obviously start with the star collapsing. But let's jump ahead to 1974. Stephen Hawking, undeniably one of the greatest scientific minds ever, made a monumental discovery. He realized mathematically that these cosmic monsters do not live forever. If you wait long enough, over trillions and trillions of years, they actually evaporate.
The mechanism for how they slowly die off is known as Hawking radiation, and it gets into some really weird quantum physics. Basically, space isn't completely empty. Right at the edge of the event horizon, tiny pairs of particles are constantly popping into existence out of absolutely nowhere. Usually they just crash back together and vanish, but right at the end of a black hole, sometimes one particle falls in, while the other particle actually manages to escape. Every single time that happens, the black hole loses a microscopic fraction of its mass. So over trillions of years of this incredibly slow leakage, the black hole just fades away. The most terrifying object in the universe eventually just ceases to exist.
Which immediately introduces a massive, glaring question. Where does the information go? Think about it. Our Stickman, his ship, the original star, all the matter and energy that ever fell into that black hole. When the black hole finally evaporates into complete nothingness, where does all of that stuff go? Does it just vanish from existence entirely? Because if it does, that completely breaks the foundational laws of physics as we understand them. This is known in the scientific community as the black hole information paradox. And the craziest part about all of this? Even as of 2026, nobody knows the answer. It remains a complete and total mystery.
Okay, let's do a really quick recap to cement everything we've covered today. First, a black hole is born from a dead star's extreme gravitational collapse. Second, the event horizon is that absolute point of no return where light itself gets trapped. Third, if you fall in, that extreme gravity gradient is going to subject you to the absolute horror of spaghettification. Fourth, they aren't immortal. They actually slowly evaporate over trillions of years via Hawking radiation. And finally, the ultimate fate of all the matter that falls inside, the information paradox, remains entirely unsolved.
But I want to leave you with one final provocative thought to chew on until next time. If absolutely nothing can escape a black hole, not even light itself, how do we actually know they're out there? More importantly, how do you take a photograph of something that by its very definition is completely invisible? Well, answering that requires a wild journey involving 8 telescopes across 5 continents, half a ton of hard drives, and an image that took 8 agonizing years to construct. It's an incredible story of human ingenuity, but that is an explainer for another day. Thank you so much for joining me on this journey into the void, and keep questioning the universe around you.